Welcome to Tech with Kaushik. This is part 14 of our complete practice question series for the AZ-104 Microsoft Azure Administrator exam. Test your knowledge with exam-focused questions covering key Azure administration concepts. Choose your answer before the timer ends, then review the correct answer, clear explanation, and practical exam tip. Let us begin part 14. Apply precise reasoning to question number 558. We are now working with AZ copy. Pay close attention to every stated constraint. A Windows server contains // logs and its subfolders. You have a destination SAS URL for an Azure Blob container, represented by destination SAS URL. You must use AZ copy v10 to upload the complete directory tree. Which command should you run? Evaluate each option against the stated requirement. Consider option A, AZ storage blob upload batch source /applogs destination SAS URL. Consider option B, ASCII sync /applogs destination SAS URL snapshot. Consider option C, ASCII copy /applogs destination SAS URL recursive equals true. Consider option D, ASCII copy /applogs destination SAS URL. The required response is option C, ASCII copy /applogs destination SAS URL recursive equals true. AZ copy v10 uses the copy command for uploads. Setting recursive equals true includes all files in the source directory and its subdirectories. The incorrect choices fail for the following reasons. A. This is an Azure CLI command, not an AZ copy command. B. The snapshot option is not the required AZ copy sync switch for this upload and the requirement is a copy operation. D. Without recursive processing, the command does not include the complete directory tree. Use ASCII copy with recursive equals true when uploading a local directory tree to blob storage. Proceed to question number 560. Review the situation. You manage a private Azure container registry named Product and several Azure container apps. The registry is not configured for repository scoped ABAC permissions. The container apps must pull images without storing registry usernames or passwords. The same identity must be reusable across multiple container apps, and it must receive pull-only access to the registry. Select the correct configuration for each requirement. Complete each statement by selecting the appropriate value. Statement 1. To reuse the same identity across multiple container apps, configure the blank. The available choices are 1. User-assigned managed identity, system-assigned managed identity, or registry admin account. Statement 2. To grant pull-only access to product, assign the identity to the blank role. The available choices are 2. ACR pull, ACR push, or contributor. The answer to the first statement is user-assigned managed identity. A user-assigned identity can be shared by multiple Azure resources. The answer to the second statement is ACR pull. ACR pull grants image pull permissions without push access. A useful examination rule is this. Use a managed identity for passwordless registry authentication and assign the narrowest data plane role required by the workload. Question number 562. Consider this scenario. You manage an Azure storage account named CorpData that stores reports. The account has the following lifecycle management rules. Rule A, applies to prefix reports /2025/. If base blobs were last modified more than 7 days ago, move them to the cool access tier. Rule B, applies to prefix reports /2025/. If base blobs were last modified more than 30 days ago, move them to the archive access tier. Rule C, applies to all blobs. If base blobs were last modified more than 365 days ago, delete them. On March 1st, you upload 2 block blobs to the hot access tier, blob 1 to reports /2025/Q1 summary.pdf, blob 2 to invoices /2025/IND001.pdf. Assume the lifecycle policy evaluation has completed before each stated date. For each statement, select yes if the statement is true. Otherwise, select No. Review Statement 1. On March 10th, Blob 1 will be stored in the Cool Access tier. Review Statement 2. On March 10th, Blob 2 will be stored in the Cool Access tier. Review Statement 3. On April 5th, Blob 1 will be stored in the Archive Access tier. Statement 1. The answer is yes. Blob 1 matches the prefix and is more than 7 days old. Statement 2. The answer is no. Blob 2 is outside the reports /2025/ prefix. Statement 3. The answer is yes. Blob 1 matches the prefix and is more than 30 days old. Remember this distinction for the exam. Lifecycle filters are evaluated before actions. A blob must match the rule filter as well as the age condition. Now consider question number 564. Scenario. You have an Azure virtual machine named WebVM01 deployed in the primary region. You need to implement an Azure backup solution for WebVM01. The backup data must remain available after a data center failure within the region by using availability zones. Which 3 actions should you perform in sequence? Review the items to be ordered. The first available item is create a new recovery services vault. The second available item is for WebVM01, create a backup policy and configure the backup. The third available item is configure a replication policy for the virtual machine. The fourth available item is set the vault storage replication type to Zone Redundant Storage, ZRS. The fifth available item is set the vault storage replication type to Locally Redundant Storage, LRS. The correct sequence is as follows. First, create a new recovery services vault. Second, set the vault storage replication type to Zone Redundant Storage, ZRS. Third, for WebVM01, create a backup policy and configure the backup. The key reason is the vault must exist before its storage replication type can be configured. ZRS provides zone-level resiliency within the region, and the replication setting must be selected before any backup is configured because it becomes locked after protection begins. Keep this examination point in mind. Set recovery services vault storage redundancy before protecting the first workload. The setting is disabled after backup is configured. The next item is question number 565. You have an Azure virtual network named vNetHub that is paired with vNetspoke. You plan to deploy an Azure Bastion Basic SKU host to vNetHub. You have several Linux virtual machines in vNetspoke. You need to configure a network security group, NSG, on the vNetspoke subnets to allow secure administrative access to the Linux virtual machines exclusively via the new Bastion host. Which destination port should you allow in the inbound security rule for the Linux virtual machines? Review the options. Choice A 22. Choice B 3389. Choice C 443. Choice D 8080. In this case, select option A 22. This is correct because Azure Bastion establishes connections to target virtual machines using their native administration ports. For Linux virtual machines, this is SSH, which uses port 22. To allow Bastion to reach the Linux virtual machines, the NSG applied to the target subnet must permit inbound traffic on port 22 originating from the Azure Bastion subnet. The remaining options are incorrect because B 3389 is the default port for RDP, used for Windows virtual machines, not Linux. C 443 is the port used by administrators to connect to the Bastion host frontend, not from Bastion to the target VM. D 8080 is an alternative HTTP port and is not used for Bastion administrative access. The key takeaway is when configuring NSGS for Azure Bastion, ensure inbound 3389, RDP, is allowed for Windows virtual machines and 22, SSH, is allowed for Linux virtual machines from the Bastion subnet. Review question number 566. Carefully. Begin by examining the scenario. You manage an HTTP-based Azure container app named Orders app. The app should scale down completely when no requests are received, but it must never scale beyond 10 replicas during periods of high demand. Select the correct replica settings. Select the value that correctly completes each statement. Review Statement 1, set the minimum number of replicas to the blank. Choose between 1, 0, 1, or 2. Review Statement 2, set the maximum number of replicas to the blank. Choose between 2, 5, 10, or 20. Statement 1 should be completed with 0. 0 minimum replicas allow scale to 0 behavior. Statement 2 should be completed with 10. 10 replicas is the required scale-out limit. Exam tip. For Azure Container Apps, minimum replicas control scale to 0 behavior and maximum replicas caps horizontal scale-out. Now consider question number 567. We are moving to resource deployment. Consider this scenario. You manage an Azure resource group named RGAppNV. You want to deploy an Azure Resource Manager, ARM, template named main.json using Azure PowerShell. The deployment must strictly match the template. Existing resources in RGAppNV that are not defined in main.json must be deleted. Select the appropriate options to complete the PowerShell command. For the first statement, new AZ resource group deployment template file main.json the blank RGAppNV. Select from 1. Resource group name, tag, or query string. For the second statement, mode the blank. Select from 2. Complete, incremental, or all. For statement 1, select resource group name. This parameter specifies the deployment target resource group. For statement 2, select complete. Complete mode removes eligible resources not declared in the template. Use ARM complete mode cautiously and run a what-if operation first because resources omitted from the template can be deleted. Question number 568. Scenario. You manage an Azure subscription named Subprod. Subprod contains an action group named AG Critical that sends SMS notifications to on-call staff. You have an Azure Monitor Activity Log Alert rule with the following configuration: scope, subprod condition, all administrative operations action, AG Critical. You create an alert processing rule with the following settings: scope, subprod rule type, suppress notification schedule, October 1st through October 3rd. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. If you delete a resource group in subprod on October 2nd, the alert will still be recorded and visible in the Azure portal. Statement 2. If you delete a resource group in subprod on October 2nd, an SMS notification will be sent to the on-call staff. Statement 3. If you create a new virtual network in subprod on October 5th, an SMS notification will be sent to the on-call staff. Statement 1 should be marked yes. Suppression affects actions, not alert creation. Statement 2 should be marked no. October 2nd is inside the suppression schedule. Statement 3 should be marked yes. October 5th is outside the suppression schedule. A useful examination rule is this. Alert processing rules can suppress or redirect actions without disabling alert rule evaluation. Proceed to question number 569. Next, we enter the topic of Storage Explorer. Review the situation. Your organization uses Azure Storage Explorer to manage storage data. You need to train a junior administrator on the operations available directly in the desktop application. You identify 4 tasks. Task A, create a new Azure storage account. Task B, upload a file as an append blob to a container. Task C, create a new file share in an existing storage account. Task D, add a new entity to an Azure table. Which tasks can be performed directly in Azure Storage Explorer? Option A, Task C, and Task D only. Option B, Task C, and Task D only. Option C, Task C and Task D only. Option D, Task A, Task B, Task C, and Task D. The best answer is option B, Task B, Task C, and Task D only. Here is the technical justification. Storage Explorer provides data plane management for blobs, Azure files, queues, and tables. It can upload a file as an append blob, create a file share in an existing account, and add table entities. Creating the Azure storage account itself is a control plane operation performed through tools such as the Azure Portal, PowerShell, CLI, or templates. The alternatives can be eliminated because A. It incorrectly includes storage account creation and omits append blob upload. C. It omits append blob upload, which Storage Explorer supports. D. It incorrectly includes creation of the storage account resource. Remember this distinction for the exam. Storage Explorer manages data and child storage resources inside an account. Create the storage account through an Azure Management Plane tool. Question number 570. Scenario. You maintain a hybrid network topology consisting of an on-premises data center connected to 3 peered Azure virtual networks, VNet A, VNet B, and VNet C. You have a total of 8 virtual machines distributed across the 3 VNets. You need to continuously monitor the network latency and connectivity from all 8 virtual machines to a specific endpoint in the on-premises data center using Azure Network Watcher. What is the minimum number of connection monitors you need to deploy? Option A 1. Option B 3. Option C 4. Option D 8. The correct answer is option A 1. The reasoning is as follows. Azure Network Watcher's connection monitor allows you to define a single connection monitor that includes multiple test groups. Within these test groups, you can define multiple source endpoints, such as multiple virtual machines across different VNets, and multiple destination endpoints, such as an on-premises IP address. Therefore, a single connection monitor is sufficient to monitor connectivity for all 8 virtual machines. Now consider why the remaining options are unsuitable. B, C, D. Connection monitor is highly scalable. You do not need a separate monitor for each VNet or each virtual machine. Keep this examination point in mind. A single connection monitor in Azure Network Watcher can handle multiple sources, destinations, and test configurations simultaneously. Let us work through question number 571. The focus now shifts to virtual networks. Review the scenario carefully. You have an Azure subscription containing 4 virtual networks: VNet East, East US, Resource Group Alpha VNet West, West US, Resource Group Alpha VNet North, North Europe, Resource Group Beta VNet Central, East US, Resource Group Beta. You plan to deploy an Azure virtual machine named VM East in East US and place the VM resource in Resource Group Alpha. To which virtual networks can the network interface of VM East be connected during deployment? Now examine the possible answers. Option A is VNet East and VNet Central only. Option B is VNet East only. Option C is VNet East and VNet West only. Option D is VNet East, VNet West, VNet North, and VNet Central. The appropriate choice is option A, VNet East and VNet Central only. The requirement is satisfied because a virtual machine's network interface must connect to a virtual network in the same Azure region as the VM. The virtual network can be in a different resource group. Both VNet East and VNet Central are in East US. The other choices do not satisfy the requirement because B, resource group membership does not require the VM to use only VNet East. C, VNet West is in West US and cannot host the NIC of an East US VM. D, VNet West and VNet North are in different regions from VM East. The key takeaway is virtual machines, NICs, and their virtual networks must be in the same region, but they do not have to be in the same resource group. The next item is question number 572. You deploy an Azure storage account to host a static website containing large media files. Global users will download these files directly from the storage account. You want to ensure that user traffic enters the Microsoft Global Network as quickly as possible, leveraging the Microsoft Edge point of presence, POP, closest to the end user. Which network setting should you configure on the storage account? The options are: Choice A, routing preference. Choice B, custom domain. Choice C, Azure Front Door Integration. Choice D, Private Endpoints. The appropriate choice is option A, Routing Preference. Routing preference in Azure Storage allows you to choose how network traffic is routed between the user and the storage account. Selecting Microsoft Network Routing, the default, ensures traffic enters the Microsoft Global Backbone via the edge point of presence, POP, closest to the user, providing lower latency and higher reliability compared to standard internet routing. B. Custom domains change the URL of the storage account but do not influence the underlying network routing path. C. While Front Door uses Microsoft's Edge network, configuring routing preference directly on the storage account achieves this without deploying a new resource. D. Private endpoints expose the storage account on a private VNet IP and are not meant for global public internet downloads. Exam tip. Configure routing preference to Microsoft Network Routing to maximize the time traffic spends on Microsoft's fast global backbone network. Let us examine question number 573. Consider the following scenario. You manage an Azure load balancer that distributes incoming HTTP traffic across a backend pool of 6 Windows Server virtual machines. The web application requires that a client's subsequent requests during a session are routed to the exact same backend virtual machine that handled their initial request. Which load balancing rule property should you configure? Choose from the following options. Choice A, Session Persistence to Client IP. Choice B, Floating IP to Enabled. Choice C, Protocol to TCP. Choice D, Idle Timeout, minutes, to 30. The required response is option A, Session Persistence to Client IP. The key reason is to ensure that requests from the same client are routed to the same backend virtual machine. You must configure session persistence, also known as session affinity. Setting it to client IP instructs the load balancer to use a 2-tuple hash, source IP, destination IP, to map traffic, guaranteeing the same client IP reaches the same backend server. The incorrect choices fail for the following reasons. B. Floating IP is used for specific scenarios like SQL always-on availability groups where the backend VM needs to see the frontend IP. It does not manage session state. C. Protocol defines whether the rule balances TCP or UDP traffic, not how sessions are maintained. D. Idle timeout keeps idle TCP connections open longer, but does not route new requests to the same server. Use Azure Load Balancer Session Persistence, Client IP, to route traffic from a specific user to the same backend instance. Now consider question number 574. Scenario. An e-commerce application runs on a scale set of Azure virtual machines behind an Azure load balancer. Users are experiencing issues with their shopping carts emptying unexpectedly. Developers determine that the load balancer is sending requests from the same user to different backend servers, breaking session state. You must ensure that traffic from a specific user IP address consistently reaches the same backend VM. What must you modify on the load balancer rule? Available choices. Option A, change session persistence from none to client IP. Option B, increase the idle timeout value. Option C, change the protocol from TCP to UDP. Option D, enable floating IP, direct server return. In this case, select option A, change session persistence from none to client IP. This is correct because by default, Azure Load Balancer distributes network traffic using a 5-tuple hash, meaning different requests from the same client might hit different backend servers if the source port changes. To maintain session state for e-commerce carts, setting session persistence to client IP ensures the load balancer uses a 2-tuple hash, routing all requests from the same client IP to the same backend VM. The remaining options are incorrect because B, increasing idle timeout prevents long-running inactive TCP connections from dropping, but does not solve session affinity. C, changing the protocol to UDP will break HTTP/HTTPS traffic. D, floating IP, direct server return, is used for specific database high availability setups, not web session persistence. A useful examination rule is this. When an application requires a user to interact with the same backend server consecutively, configure session persistence to client IP. We will now analyze question number 575. Let us first review the situation. You have an Azure subscription containing 50 virtual machines across multiple virtual networks. Network telemetry is sent to a central log analytics workspace. You want to use traffic analytics to visualize network traffic flows and detect communication with known malicious IP addresses. What must you configure to gather the flow data required by traffic analytics for a new deployment? Review each available choice. Choice A, Virtual Network Flow Logs. Choice B, Azure Network Watcher Connection Monitor. Choice C, a data collection rule for the virtual machines. Choice D, the Azure Monitor agent on every virtual machine. The best answer is option A, Virtual Network Flow Logs. Here is the technical justification. Traffic Analytics analyzes Network Watcher flow log data. For a new deployment, Virtual Network Flow Logs are the supported replacement for NSG flow logs and provide the traffic records that Traffic Analytics processes. The alternatives can be eliminated because B, Connection Monitor actively tests connectivity and latency. It is not the flow log data source for Traffic Analytics. C, Data collection rules configure Azure Monitor agent collection, not Network Watcher flow logging. D, flow logs are collected by the Azure platform and do not require an agent on each VM. Remember this distinction for the exam. Use virtual network flow logs for new traffic analytics deployments. Creation of new NSG flow logs is no longer supported. The next item is question number 576. Consider this scenario. You configure Azure Site Recovery for a virtual machine named VMDB. VMDB is in East US and is connected to SubnetDB in VNet East. You replicate VMDB to West US. The recovery virtual network is VNet West, which contains Subnet App, Subnet Web, and Subnet Recovery. For both an actual failover and an isolated test failover, the recovered VM must use a subnet named Subnet Recovery. The isolated test virtual network contains a subnet with that same name. What should you configure before running the test failover? Available choices. Choice A. In the replicated items compute and network settings, set the target subnet to Subnet Recovery. Choice B. Rename Subnet Recovery to match the address prefix of SubnetDB. Choice C. Configure the same network security group on Subnet Recovery and SubnetDB. Choice D. Associate VNet West directly with the Recovery Services Vault. The correct answer is option A. In the replicated items compute and network settings, set the target subnet to Subnet Recovery. The reasoning is as follows. Site Recovery uses the target subnet configured for the replicated item. During a test failover, it attempts to place the test VM in a subnet with the same name in the selected test virtual network. Configuring Subnet Recovery and providing a same-named isolated subnet produces the required placement. Now consider why the remaining options are unsuitable. B. Subnet selection is based on configured network settings and subnet name, not by renaming a subnet to an address prefix. C. Matching NSGS does not control which subnet Site Recovery selects. D. Virtual networks are selected in replication and failover settings. They are not associated directly with a vault. Keep this examination point in mind. Configure the replicated item's target network and subnet before failover, and use matching subnet names in an isolated test network for predictable test placement. Question number 577. This question moves us into network security groups. Review the situation. You manage a virtual network containing a single subnet named Workload Subnet. Two virtual machines, AppVM and DBVM, are connected to the subnet. You must prevent only AppVM from initiating SSH connections to DBVM. No other traffic from AppVM or between other resources should be affected. What is the most targeted configuration? Option A. Create an NSG outbound rule that denies traffic to DBVM's private IP address on destination port 22, and associate the NSG with AppVM's network interface. Option B, create an NSG inbound rule that denies destination port 22, and associate the NSG with workload subnet. Option C. Add DBVM to an application security group and create a subnet-level inbound rule that denies all SSH traffic to the application security group. Option D, configure Azure Firewall and route all intra-subnet traffic through the firewall. The appropriate choice is option A, create an NSG outbound rule that denies traffic to DBVM's private IP address on destination port 22, and associate the NSG with AppVM's network interface. The requirement is satisfied because the NIC-scoped outbound rule applies only to AppVM, and the destination IP and port restrict the denial to SSH traffic sent specifically to DBVM. Other AppVM traffic and other resources remain unaffected. The other choices do not satisfy the requirement because B, a subnet-level rule can affect every resource in workload subnet. C, the subnet-level rule would deny SSH to DBVM from more sources than AppVM unless additional source constraints were added. D, Azure Firewall and forced routing are unnecessary for a single targeted east-west restriction. The key takeaway is for the narrowest NSG effect, combine NIC scope with specific source or destination addresses and ports. Let us work through question number 578. Let us first review the situation. A gaming application is hosted on 3 Azure virtual machines. An internal Azure load balancer routes UDP traffic to the virtual machines. During gameplay, a player's client application sends frequent status updates. The application architecture requires that all updates from a given player are processed by the same virtual machine to maintain real-time state. Which load balancing configuration satisfies this requirement? Compare the following options. Option A is set session persistence to client IP. Option B is enable TCP reset on idle. Option C is configure a health probe on port 443. Option D is set session persistence to none. The best answer is option A, set session persistence to client IP. To route traffic from the same client to the same backend virtual machine consecutively, you must configure session persistence, session affinity. By setting it to client IP, the load balancer uses the source IP address to consistently hash and route the player's UDP traffic to the same web server. B. TCP reset on idle is for TCP connections and drops idle connections cleanly. It does not apply to UDP or session state. C. A health probe determines if a backend VM is healthy and eligible to receive traffic. It does not control session affinity. D. Setting session persistence to none will distribute requests across all available virtual machines using the default 5-tuple hash, breaking the required stateful connection. Exam tip. Azure Load Balancer supports session persistence for both TCP and UDP traffic using a 2-tuple, client IP, or 3-tuple, client IP and protocol, hash. Proceed to question number 579. You manage an Azure subscription with the following activity log alert rules. Alert Rule A is scoped to VM backend and has the condition all administrative operations. Alert Rule B is scoped to resource group RG Compute and has the condition all administrative operations. VM backend is an RG Compute. Admin 1 resizes VM backend. Admin 2 creates an Azure policy assignment at the RG Compute scope. Select the alert rules triggered by each administrator's action. Choose the correct entry for every drop-down field. The first statement reads, Admin 1, the blank. The options for this statement are 1. Alert Rule A and Alert Rule B trigger, only Alert Rule A triggers, only Alert Rule B triggers, or no alert triggers. The second statement reads, Admin 2, the blank. The options for this statement are 2. Alert Rule A and Alert Rule B trigger, only Alert Rule A triggers, only Alert Rule B triggers, or no alert triggers. The correct value for Statement 1 is Alert Rule A and Alert Rule B trigger. The resize is within both the VM scope and the containing resource group scope. The correct value for Statement 2 is only Alert Rule B triggers. The policy assignment is an administrative operation at RG Compute, not on VM backend. An activity log alert scoped to a resource group includes administrative events for the group and its contained resources. The next item is question number 580. We are moving to VNet peering. Scenario. You are an Azure administrator managing two virtual networks, VNet Core and VNet Edge. VNet Core contains a virtual machine named DCVM1. VNet Edge contains a virtual machine named ProxyVM1. Both virtual networks are in the same Azure region but belong to different resource groups. You need to allow direct, private IP communication between DCVM1 and ProxyVM1 while minimizing the configuration and management overhead. What should you do? Review the options. Choice A. Establish virtual network peering between VNet Core and VNet Edge. Choice B. Configure a VPN gateway in each virtual network and establish a site-to-site connection. Choice C. Deploy an Azure firewall and a hub virtual network and route traffic through it. Choice D. Create an inbound security rule in the network security groups associated with both virtual machines. The required response is option A. Establish virtual network peering between VNet Core and VNet Edge. The key reason is virtual network peering allows you to seamlessly connect two or more Azure virtual networks. Once peered, the virtual networks appear as one for connectivity purposes, allowing virtual machines in the peered networks to communicate directly via their private IP addresses. This is the least complex and lowest overhead solution. The incorrect choices fail for the following reasons. B. A VPN gateway provides site-to-site connectivity but incurs higher costs, lower bandwidth limits, and significant configuration overhead compared to peering. C. Deploying Azure Firewall requires routing configuration and peering anyway, adding unnecessary cost and effort for basic VNet to VNet communication. D. Modifying NSGS allows traffic through the firewall rules, but it does not establish the routing path required between separate VNets. A useful examination rule is this. Use VNet peering to provide high bandwidth, low latency, private IP connectivity between VNets within Azure without the need for gateways. Question number 581. Consider this scenario. You migrate an on-premises Active Directory domain services environment to Azure. You deploy VNet identity with address space 172.16.0.0/16 and subnet DC with 172.16.1.0/24. You migrate a domain controller to an Azure virtual machine named Availability Zone DC01 in subnet DC. Availability Zone DC01 is the primary DNS server for Corp Local. New member servers in VNet identity must automatically use Availability Zone DC01 for name resolution. Select the appropriate configuration options. Review each blank and choose the most appropriate option. For the first statement, the private IP address allocation for Availability Zone DC01 in Azure should be set to the blank. Choose between 1. Static, dynamic, public, or unassigned. For the second statement, to provide Availability Zone DC01 as the DNS server to member servers, you must the blank. Choose between 2. Configure VNet identity to use a custom DNS server, create an Azure private DNS zone for Corp Local, configure VNet identity to use Azure provided DNS, or configure a DNS forwarder in Azure Firewall. The correct value for statement 1 is static. The DNS server must retain a stable private IP address. The correct value for statement 2 is configure VNet identity to use a custom DNS server. The VNet DNS setting distributes the domain controller's address through DHCP. Remember this distinction for the exam. Set an Azure VM's private IP allocation to static on the NIC, and configure custom DNS at the VNet when all attached virtual machines should use that DNS server. Now consider question number 582. This question moves us into ARM templates. Review the situation. You review an Azure Resource Manager template that deploys an internal Azure load balancer. The Variables section contains variables, VNet ID, Resource ID, Microsoft, Network/Virtual Networks, VNet Front, LB Name, LB Internal, SKU Type, Standard, Subnet Name, frontend subnet. The frontend IP configuration references this subnet ID, concat, variables, vnet ID, subnets, variables, subnet name. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is, the load balancer frontend will be connected to a subnet named frontend subnet. The second statement is, the resource ID function as written resolves vnet front in the same resource group as the deployment. The third statement is, you can override SKU type by passing an inline template parameter named SKU type to new AZ resource group deployment without modifying the template. The answer to statement 1 is yes. The subnet name variable is appended to the vnet resource ID. The answer to statement 2 is yes. No alternate resource group argument is supplied. The answer to statement 3 is no. Only values declared in the templates parameters section can be supplied as deployment parameters. Keep this examination point in mind. ARM variables are internal calculated values. Expose a value in the parameters section when it must be supplied at deployment time. Proceed to question number 585. You store 8 terabytes of historical compliance records as block blobs in a general-purpose V2 storage account configured with locally redundant storage. The records are expected to remain unread for several years. Retrieval can take several hours when a record is requested, and you must minimize storage cost. Which access tier should you use for the records? The options are: Option A, hot. Option B, cool. Option C, cold. Option D, archive. In this case, select option D, archive. This is correct because the archive tier has the lowest storage cost for block blobs that are rarely accessed and can tolerate offline rehydration before reading. The account's LRS configuration supports the archive tier. The remaining options are incorrect because A, hot has the highest storage cost and is intended for frequently accessed data. B, cool is online and better for infrequently accessed data that still requires immediate retrieval. C, cold is also online and costs more to store than archive for long-term, rarely read data. The key takeaway is archive is an offline tier, rehydrate a blob to an online tier before reading it, and account for the minimum retention period. Now consider question number 587. Review the situation. You configure lifecycle management rules on a blob storage account. You create 3 rules that evaluate daily on all base blobs. Rule X, move to cool storage if last modified more than 10 days ago. Rule Y, move to archive storage if last modified more than 10 days ago. Rule Z, delete the blob if last modified more than 10 days ago. On September 1st, you upload a new blob to the hot access tier. No subsequent modifications are made to this blob. What will the state of the blob be on September 12th? After the rules have been fully evaluated by the background process? Option A. The blob will be deleted. Option B. The blob will be in the archive access tier. Option C. The blob will be in the cool access tier. Option D. The blob will remain in the hot access tier due to conflicting rules. The correct answer is option A. The blob will be deleted. Here is the technical justification. Azure Storage Lifecycle Management rules execute sequentially. If multiple rules define an action for the same blob based on the same timeframe, the storage platform applies the action with the lowest cost. Deletion takes precedence over tiering, and tiering to archive takes precedence over tiering to cool. On September 11th, 10 days old, the background process evaluates the rules. Rule Z dictates deletion, which overrides the tiering rules. By September 12th, the blob is deleted. The alternatives can be eliminated because B, archive tiering is overridden by the deletion rule. C, cool tiering is overridden by the archive and deletion rules. D, rules do not conflict in a way that stops execution. Azure automatically prioritizes deletion. Exam tip. If a blob matches multiple lifecycle management rules on the same day, deletion always takes priority over any tiering change. Let us examine question number 588. Review the scenario carefully. You plan a storage architecture using 3 Azure storage accounts: Account A, Storage v2 with GeoZone Redundant Storage, GZRS, Account B, Blob Storage with Read Access Geo-Redundant Storage, RAGRS, Account C, Premium Block Blob Storage with Zone Redundant Storage, ZRS. Select the storage accounts that support each feature. Complete each statement by selecting the appropriate value. The first statement reads, Lifecycle management policies are supported by the blank. The available choices are 1. Account A, Account B, and Account C, Account A and Account B only, Account A only, or Account C only. The second statement reads, Moving block blobs to the archive access tier is supported by the blank. The available choices are 2. Account B only, Account A and Account B only, Account A, Account B, and Account C, or Account A only. For Statement 1, select Account A, Account B, and Account C. All 3 account kinds support lifecycle management policies. For Statement 2, select Account B only. RAGRS supports Archive, GZRS and Premium Block Blob Storage do not. Archive tier requires a standard LRS, GRS, or RAGRS account. It is unavailable with zone redundant configurations and Premium Block Blob Storage. Review question number 589. Carefully. Begin by examining the scenario. Your company recently deployed multiple Azure virtual networks peered across 3 regions. You have also configured Azure Express route circuits for hybrid connectivity. The network team requests a centralized dashboard within the Azure portal that provides a visual representation of the entire network topology, alongside detailed performance metrics and health statuses of all network resources. Which Azure monitoring feature best satisfies this request? Compare the following options. Choice A, Azure Monitor Network Insights. Choice B, Azure Network Watcher IP Flow Verify. Choice C, Azure Monitor Application Insights. Choice D, Log Analytics Workspace Custom Workbooks. In this case, select option A, Azure Monitor Network Insights. The reasoning is as follows. Azure Monitor Network Insights provides a comprehensive and dynamic visual representation of your network topology, including health and performance metrics. It discovers and visualizes dependencies between network resources such as VNets, subnets, and express route circuits directly within a centralized Azure Monitor dashboard. Now consider why the remaining options are unsuitable. B. IP Flow Verify is a troubleshooting tool for checking NSG rules on a specific VM, not a topology visualization tool. C. Application Insights monitors application-level code performance and APM topology, not underlying infrastructure network topology. D. While custom workbooks can display data, Network Insights provides an out-of-the-box topology visualization specifically designed for this exact purpose. A useful examination rule is this. Use Azure Monitor Network Insights when you need a comprehensive, visual topology map of your network resources alongside health metrics. The next item is question number 590. Scenario. You manage a complex Azure environment consisting of 3 peered virtual networks across different regions. Each subnet restricts traffic using heavily customized network security groups, NSGS. A developer reports that an application on VM frontend, region A, is unable to connect to a database on VM backend, region B, over TCP port 5432. You suspect an NSG rule is blocking the traffic, but due to the number of rules, it is difficult to identify the culprit manually. Which 2 Azure Network Watcher tools can you use to actively test the connection and identify if an NSG is dropping the packets? You need to identify 2 correct options. The options are Choice A, IP Flow Verify. Choice B, Connection Troubleshoot. Choice C, VPN Diagnostics. Choice D, NSG Flow Logs. Choice E, Packet Capture. The choices that satisfy the requirement are option A, IP Flow Verify, and option B, Connection Troubleshoot. The requirement is satisfied because IP Flow Verify is a feature of Azure Network Watcher that checks whether a packet is allowed or denied to or from a virtual machine. The tool analyzes NSG rules and informs you exactly which security rule is dropping the packet. Connection Troubleshoot checks the end-to-end TCP/IP connection from a source VM to a destination, identifying routing issues, NSG blocks, and providing actionable insights if a port is unreachable. The other choices do not satisfy the requirement because C. VPN Diagnostics troubleshoots VPN gateway configurations, not VM-to-VM traffic across peered VNets. D. NSG Flow logs record historical traffic logs to a storage account. They are not an active testing tool to immediately diagnose a blocked port. E. Packet Capture captures raw network data, which is useful for deep inspection, but IP Flow Verify and Connection Troubleshoot are the primary, direct tools for identifying NSG blockages. Remember this distinction for the exam. To quickly identify which specific NSG rule is blocking traffic for AVM, use Network Watcher's IP Flow Verify. We will now analyze question number 591. Consider the following scenario. You deploy an internal Azure load balancer to distribute traffic to a scale set of Linux virtual machines. The application requires that once a user establishes a connection on a specific port, all subsequent requests from that user's IP address and protocol combination are routed to the same Linux virtual machine for the duration of the session. Which setting should you configure on the load balancing rule? Now examine the possible answers. Option A is session persistence to client IP and protocol. Option B is floating IP, direct server return, to enabled. Option C is idle timeout, minutes, to 15. Option D is session persistence to none. The appropriate choice is option A, session persistence to client IP and protocol. Setting session persistence, affinity, to client IP and protocol uses a 3-tuple hash, source IP, destination IP, protocol, to route traffic. This ensures that a client connecting from the same IP address using the same protocol, for example, TCP, will be consistently routed to the exact same backend Linux virtual machine for the duration of the session. B. Floating IP, direct server return, allows backend instances to respond directly using the frontend IP. It does not handle session stickiness. C. Idle timeout determines how long inactive connections stay open, not which server handles new requests. D. Session persistence to none forces a 5-tuple hash, which breaks session stickiness if the client's source port changes. Keep this examination point in mind. Use client IP or client IP and protocol session persistence on an Azure load balancer to guarantee stateful session routing. Question number 592. You have an Azure subscription named Subfinance. Within Subfinance, there is a resource group named RG Network which contains a virtual network named VNetProd. An administrator named Admin1 currently holds the reader and security admin built-in roles at the subscription level. You need to grant Admin1 the ability to assign the reader role specifically for VNetProd to other team members. The solution must follow the principle of least privilege. What should you do? Available choices. Option A, assign Admin1 the role-based access control administrator role for VNetProd. Option B, assign Admin1 the network contributor role for VNetProd. Option C, assign Admin1 the owner role for Subfinance. Option D, assign Admin1 the contributor role for RG Network. The best answer is option A, assign Admin1 the role-based access control administrator role for VNetProd. The key reason is to assign roles to other users. A principal requires the Microsoft authorization/role assignment/write permission. The built-in role-based access control administrator, or user access administrator, role provides this exact permission. By scoping this assignment strictly to VNetProd, Admin1 is granted the least privilege required to manage access for that specific resource. The incorrect choices fail for the following reasons. B. The network contributor role allows managing network resources, but it does not allow assigning RBAC roles to other users. C. The owner role grants full access, including role assignments, but assigning it at the subscription level violates the principle of least privilege. D. The contributor role allows managing resources but explicitly denies managing role assignments. The key takeaway is the role-based access control administrator and user access administrator roles are required to grant access to other users. Scope it as tightly as possible to adhere to least privilege. Let us focus on question number 593. Focus on the following situation. You deploy an Azure virtual network named vNetApp. The virtual network contains the following resources: VM Linux, an Azure virtual machine running Ubuntu, Web App Main, an Azure App Service web app integrated with the VNet, storage data, an Azure storage account using a private endpoint in the VNet. You deploy an Azure Bastion host into a dedicated subnet within vNetApp. Which of the resources can you directly access and manage using the Azure Bastion host? The relevant choices are as follows. Option A, VM Linux only. Option B, Web App Main only. Option C, VM Linux and Web App Main only. Option D, VM Linux, Web App Main, and storage data. The required response is option A, VM Linux only. This is correct because Azure Bastion provides secure and seamless RDP and SSH connectivity to virtual machines directly from the Azure portal over TLS. It is designed specifically to protect and provide administrative access to Azure virtual machines, like VM Linux. It does not provide direct administrative connectivity to PaaS services like Azure App Service or Azure Storage accounts. The remaining options are incorrect because B, C, D, Azure Bastion cannot be used to connect to an app service web app or a storage account. It is exclusively for VM-based RDP SSH traffic. Exam tip. Azure Bastion is an infrastructure as a service (IaaS) protection tool used exclusively to broker RDP and SSH connections to virtual machines. Let us work through question number 594. Let us first review the situation. You are modernizing a legacy application using Azure Container Instances, ACI. You plan to deploy a multi-container group that shares the same lifecycle, local network, and storage volumes. You have 4 prepared container images: Image A, Linux, Jinx, Image B, Linux, Red ISS, Image C, Windows Server Core 2019, IIS, Imaged, Nano Server 2019, .NET API. Which of these images can be successfully deployed together into a single multi-container group in Azure Container Instances? Review each available choice. Choice A, Image A and Image B only. Choice B, Image C and Imaged only. Choice C, Image A, Image B, Image C, and Imaged. Choice D, Image A and Image C only. The correct answer is option A, Image A and Image B only. Here is the technical justification. In Azure Container Instances, ACI, a multi-container group allows multiple containers to share the same lifecycle, network, and storage. However, multi-container groups are currently supported only for Linux containers. Windows containers, such as Windows Server Core and Nano Server, only support deployment as single container groups. Therefore, only the Linux images, Image A and Image B, can be deployed together. The alternatives can be eliminated because B, Image C and Imaged are Windows containers, which do not support multi-container groups in ACIC. You cannot mix Linux and Windows containers in the same container group, nor can Windows participate in a multi-container group. D, Image C is Windows, so it cannot be grouped with Image A. Azure Container Instances supports multi-container groups, sidecar patterns, exclusively for Linux containers. Proceed to question number 595. Next, we enter the topic of Azure Monitor logs. Consider this scenario. You manage an environment with 150 Azure virtual machines running Windows Server. You need to collect Windows event logs, including system and security events, and specific performance counters from all virtual machines. The collected data must be routed to 2 distinct log analytics workspaces for different teams to analyze. What is the recommended agent to install and configure on the virtual machines to fulfill this requirement? Review the options. Choice A. The Azure Monitor Agent, AMA. Choice B. The Log Analytics Agent, MMA. Choice C. The Azure Diagnostics Extension, WAD. Choice D. The dependency agent. The appropriate choice is option A. The Azure Monitor Agent, AMA. The reasoning is as follows. The Azure Monitor Agent, AMA, replaces older monitoring agents, like the Log Analytics Agent, WAD, and Telegraph. It uses data collection rules, DCRs, to securely collect logs, including Windows events, and performance metrics, and it natively supports multi-homing routing data to multiple destinations, including distinct log analytics workspaces. Now consider why the remaining options are unsuitable. B. The Log Analytics Agent, MMA, is deprecated/retired and replaced by the Azure Monitor Agent. C. The Azure Diagnostics Extension, WAD, sends data to Azure Storage, Azure Monitor Metrics, or Event Hubs, but AMA is the modern standard for routing logs to log analytics workspaces. D. The dependency agent maps network dependencies for VM insights but relies on AMA to collect event logs. A useful examination rule is this. Azure Monitor Agent, AMA, combined with data collection rules, DCRs, is the modern standard for collecting and routing logs and metrics from Azure virtual machines. Question number 596. Now, you manage a storage v2 account named raw.sa in central US. A container named inbound receives continuous uploads of block blobs. A data analytics team requires an asynchronous copy of those block blobs in a separate storage v2 account named Analytics SA in East US. You want a native storage feature and do not want to maintain custom scripts. Which Azure storage feature should you configure? Options. Option A, Object Replication. Option B, Geo-redundant storage failover. Option C, Scheduled AZ copy scripts. Option D, Lifecycle management rules. In this case, select option A, Object Replication. The requirement is satisfied because object replication asynchronously copies block blobs between containers in separate storage accounts. It provides native cross-account replication after the required versioning, change feed, and replication policy prerequisites are configured. The other choices do not satisfy the requirement because B. GRS uses a Microsoft-selected paired region and does not replicate to a chosen storage account or container. C. Scheduled AZ copy can transfer data but requires external scheduling and maintenance. D. Lifecycle management changes tiers or deletes objects. It does not copy them to another account. Remember this distinction for the exam. Use object replication for asynchronous blob copies between selected source and destination accounts. Enable its storage prerequisites first. Proceed to question number 597. The focus now shifts to action groups. Consider this scenario. You configure an Azure Monitor alert rule that triggers whenever CPU utilization on a critical virtual machine, VM primary, exceeds 95% for 5 minutes. When this alert triggers, you want to automatically invoke a specific Azure function, funcscaleout, to perform custom remediation tasks. What must you create and link to the alert rule to ensure the Azure function is executed? Review the options. Choice A. An action group. Choice B. An alert processing rule. Choice C. An application security group. Choice D. A logic app workflow. The best answer is option A. An action group. Action groups in Azure Monitor define a collection of notification preferences and automated actions. When an alert triggers, it calls the assigned action group. To run an Azure function in response to an alert, you configure an action group and add the Azure function as one of its defined actions. B. Alert processing rules modify the behavior of fired alerts, like suppressing notifications or modifying which action group is called, but they do not contain the function execution logic themselves. C. An application security group, ASG, groups VM network interfaces for NSG rules. It has nothing to do with alerts. D. While a logic app can be triggered by an action group, the immediate resource you must attach to the alert rule itself is the action group. Keep this examination point in mind. Azure Monitor alerts execute automated remediation tasks, such as triggering runbooks, webhooks, or Azure functions, by referencing an action group. You have completed Part 14 of the AZ-104 Microsoft Azure Administrator Exam Practice Series. Keep building your Azure administration skills by opening the complete playlist and continuing with the remaining parts in sequence. If this session helped your preparation, like the video, subscribe to Tech with Kaushik, and enable notifications for more certification exam practice content. Share your score, doubts, or feedback in the comments. I would be happy to hear how your preparation is going. Thank you for learning with Tech with Kaushik. Keep practicing, and I will see you in the next part.